Well, thank you very much. I would like to thank the organizer for including our paper in this beautiful program. This is a joint work with Mara Faccio from Purdue and Roberto Mura from Manchester Business School. So as the title suggests, in this paper what we want to look at is the role played by CEO gender in corporate decisions. And in particular, what we look at are risk-taking decisions. So once we find evidence that there is indeed a significant impact of CEO gender in risk-taking decisions, we want to ask why. So we want to investigate going a step forward and try to find out the mechanism that explain our gender-related difference in propensity to undertake risk. So why do we investigate this? Why do we ask these research questions? If we look at the literature in economics and psychology, we find a plethora of evidence showing that there is indeed a gender-related difference in risk-taking. And across different fields, we do find a common result. And the result is that women, on average, tend to undertake less risky decisions than men. When we move in our field, so in corporate finance, we find definitely that there is more scarce evidence. And most of these studies that look at the gender-related difference are based on board diversity. So they look at the fraction of women in the board and the role played by the fraction of women in corporate decisions and outcomes. And we do find empirical evidence showing that there is indeed an effect of this fraction of women in the board. The question is whether this gender-related difference extends also at the top level, at corporate decision makers, top management, the CEOs. And in this case, the evidence in corporate finance is indeed very, very small. So our paper wants to contribute to this literature by providing a more systematic evidence of a gender-related difference effect in corporate decision, in risk-taking decisions. And we do find that female CEOs tend to undertake less risky decisions than male CEOs. But also, there is a small but growing literature in corporate finance on managerial traits, managerial preferences, the importance of managerial traits and managerial preferences and how this shape corporate decisions and outcomes. So we provide evidence that gender is indeed another trait that affects corporate decision. And we want to go one step further and try to understand the mechanism behind this gender-related difference. So what we do is to take a number of different explanations provided by economics, psychology, corporate finance literature, and try to see which ones can better explain our results. So this is the second part of the analysis. So in order to perform this analysis, answer these questions, we use data from Amadeus Top 250,000. So Amadeus is one of these products from Bureau van Dijk that provide data on a very large sample of European, both public and private companies. So providing data, accounting data, ownership data, to a certain extent CEO gender data. And we collect this information from 1999 to 2009. So we couple Amadeus data with several other sources to gather information on loans, pay structure, labor market characteristics, altruism, and social norms that we will use in the second part of the analysis. So after combining all the databases and cleaning all the data, we end up with a final sample of more than about 400,000 firm-year observations, and that counts for about 150,000 unique firms. Now, in terms of the variables that we use, definitely the main variable in our analysis is the CEO gender. So CEO gender is a dummy that is equal to 1 if the company is run by a female CEO, and 0 otherwise. So in order to identify the gender of the CEO in our sample, so we undertook a number of steps. So we started from Amadeus, and from the information, sometimes scattered information provided by this database. So we used the CEO gender when it was available for the last 3 years of our database, and we used, when possible, the salutation, so Mr. versus Miss, and so on and so forth, in different languages. We then computed a number of country-specific lists of first names in order to identify the gender of the CEO by first name. And when these two steps were not sufficient to identify the gender, we ended up looking again on the website, so social networks like Facebook, LinkedIn, or Google, more simply, OneSource, to find out some pictures, some small bios that could help us identifying the gender. So we ended up with a list of about 25,000 unique first names, and in our database, almost 10% of the observations have a female CEOs, which is quite a high percentage, but we need to remember that in this database, many of the companies, the majority of the companies are private companies, and this counts a lot. In terms of the risk-taking decision, so the left-hand side of our regressions, we use 3 alternative variables to approximate risk-taking decisions. So we'll use leverage to approximate the riskiness in financial decisions. And we use the volatility of return on asset to approximate the riskiness in investment decision, outcome decisions. So we require companies to have at least 5 years of observation for ROA in order to compute this volatility over 5 years of overlapping panels. So to limit, overcome, control, if you want, some of the shortcomings of this sigma ROA, like for instance, potential criticism of earnings manipulation or survivorship bias, we use an alternative variable to approximate the riskiness in outcomes, which we call it the likelihood of survival. And that is simply a dummy equal to 1 if the company exists in our database for at least 5 years, and 0 otherwise. Just a glimpse of the data, simple univariate analysis, we seem to find a difference, a significant difference in risk-taking decisions across these 2 subsamples of companies. But of course, this is just a univariate analysis. We need something more. So what we do is to start with an OLS regressions, including country, industry, year fixed effects, and a number of control variables coming from the financial statement of the company, from the ownership structure of the company. And as you can see, what we find is a consistent result across all our proxies of risk-taking, which shows that there is indeed, or there seems to be, a gender-related difference in risk-taking. And in particular, what we find is that female CEOs tend to undertake less risky decisions than male CEOs. These results are statistically significant, but are also economically important. If we look at, for instance, leverage, what we find is that the female companies run by female CEOs tend to have 3% less leverage than male CEOs, which is quite a large number if compared to the average leverage in our sample, which is 36%. So we have almost a 10% fall. But there is always a big but in our corporate finance studies. These results are appealing, but could be affected by a well-known problem that we have in our studies, the endogeneity issue. And in particular, in this type of analysis, the source of endogeneity comes from a selection problem. So the fact that gender could be a selection criteria for companies when they hire a CEO. So a company with certain characteristics could hire a CEO with a certain gender that fits the risk profile of the company. So in order to control for this potential endogeneity issue that will bias our interpretation, because the causality will run from the left-hand side to the right-hand side and not the other way around, we undertook a number of steps. So the first one was the propensity score matching estimation, when basically the idea is to construct two subsamples of companies that are equal, virtually similar in all observable characteristics, except one, the CEO gender. So the idea of causality here is that if these observable characteristics affect both the left-hand side and the right-hand side, then we shouldn't find any significant difference in risk-taking. But what we see in here, this is the first experiment we do within this family. So we construct these subsamples within the same country, industry year, and private-public status, conditioning all the observable characteristics that we have in the baseline model. We still find a significant difference in risk-taking. We also do two variations in this setting. So we include also those, for a subsample of companies, those CEO characteristics that we have found in terms of age and equity wealth, and results are similar to these ones. And we also use a subsample of transition companies, so those companies that experience a change in the CEO gender, and we still find the same result. The limitation of this type of analysis is that it is based on observable characteristics. So what if this selection problem is caused by unobservable characteristics? So what we do is to exploit the panel data dimension of our database, and we run firm-fixed effects on the transition sample. And we do find similar results from our baseline regression, so still a gender-related difference in risk-taking. Limitation in this firm-fixed effect is based on the assumption of firm-fixed effect, which is that these unobservable form characteristics are time invariant. So what we do as a final step is to relax this assumption and try to control for firm characteristics and observable characteristics that are variant over time. So we perform two alternative Ekman two-stage models. So with the Ekman, we basically explicitly perform on a first stage regression the likelihood, the probability to hire a female CEO. We propose a novel instrument in order to improve the identification, and basically what we propose as an instrument, so as a variable that affects the probability to hire a female CEO without affecting risk-taking, we use the fraction of firms with a female CEOs over all those firms where the male directors of our company, the company of our interest, serve as a director. So once we have our first stage regression sorted, we run two variations of the Ekman model. One is the counterfactual analysis, so basically where we compare the actual level of risk-taking for instance, companies run by a female CEO with the counterfactual values of risk-taking, so the risk-taking of the company as if that company had been run by a male CEO. So the expectation is that the actual values should be lower than the counterfactual. And indeed, this is what we find here. The second experiment we do within the Ekman family is the treatment effect model. So we run a second stage regression, so basically the same baseline model augmented with the inverse miss ratio, which should capture and clean the OLS estimates from the self-selection bias, and we still find a significant gender-related difference across all our proxies of risk-taking. So we have, across different types of experiment, different types of tests, a consistent result. So a gender-related difference and female CEOs that tend to undertake less risky decisions than male CEOs. So with the final part, what we want to find is an explanation, the mechanism that try to explain or justify this gender-related difference. So what we did was to look at 8 different potential mechanisms that we drove from economics, psychology, corporate finance. And what we found was that differences in risk aversion across genders, and a difference in altruism, so being more concerned about others across genders, and differences in social norms, so institutional settings, societies that have more or less favorable attitude towards women are the mechanism that seems to explain better our results. So I can conclude that with this paper we have two main evidence. The first one definitely is that we provide evidence on a gender-related difference in corporate risk-taking. So CEO gender indeed plays a role, a significant role in shaping the risk-taking decision of our companies. And the second one, which is a step forward with respect to previous papers, is to provide some more explanation of why this is the case. And so we find that risk aversion, altruism, and social norms are the stories behind our first results. Thank you.
Thank you very much.